Beckett, and I'm from iVEC, and I'm going to give the Australia status report today. So, Australia has a range of different scientific and supercomputing institutions. We have two nationally funded institutions, which is the National Computational Infrastructure, NCI, and the Pawsey Supercomputing Centre, which is managed by iVEC, where I work. And we also have a range of specialised facilities in research centres in areas such as computational imaging, life sciences, astrophysics, and the like. If we look at it on the map, there is a certain weighting of or clustering of these centres. So over in the west there we have iVEC, which is at the end of a very large desert effectively, and then most of our other computational centres are clustered around either Victoria and Melbourne or Canberra, the capital ACT. But thankfully we do have the Australian Academic Research Network. This is a slightly old slide now. Thankfully these are too small to read, but it does say 10 gigabits per second there. I'm pretty sure almost all that network now is 40 gigabits per second, then we have a plan to grow that to 100 gigabits per second in the coming years. The National Computational Infrastructure covers the whole breadth of Australian research. It aims to provide world-class infrastructure to support the many and varied research areas that are of interest to Australia. Its main machine, which was brought into production last year, is called Ryujin. It's a 1.2 petaflop system based on Intel Sandy Bridge processors, and it's backed by a 10 petabyte dedicated storage system. NCI aims to provide an end-to-end solution. It's not just about supercomputing. They also run a node of the Australian National Cloud Service, which is called Nectar, and they also have significant storage resources, around about 50 petabytes shared between tape and disk-based storage for collections of national significance. iVEC, where I work, has three focus areas. We are focused on supercomputing, on data-intensive research, and on scientific visualization. Main scientific areas are radio astronomy, as many of you will know, and probably those who have recognised the Pawsey Centre. We are part of the Australian contribution to the Square Kilometre Array project, and we are running both of the Australian Pathfinder telescopes, or providing the compute infrastructure for both of the Australian Pathfinder telescopes. But we also have a significant interest in geosciences. Australia is a mineral-rich country, and Western Australia in particular has significant iron ore and other mineral resources, and that attracts a critical mass of expertise in geosciences to Western Australia, which effectively means Perth, and we support those with computational infrastructure. And then through the university partners we have significant research in the usual fields, so computational chemistry, physics, engineering, earth sciences, biosciences, and bioinformatics, to name just a few. We have two supercomputers at the moment. Our main general purpose machine, which isn't actually quite here yet, it's due to arrive in a few weeks' time, called Magnus, will be a 1+ petaflop system from Cray. It's backed by a 3 petabyte Lustre file system. And we also have a smaller Cray system called Galaxy, which is dedicated to radio astronomy research and the operation of those two Pathfinder telescopes that I told you about earlier. We also have a significant storage facility. We have capacity for up to 100 petabytes of tape, which is roughly 5 years of operation of the two Pathfinder telescopes. And that's fronted by a 6 petabyte disk pool, which gives us an HSM system as well as other research file systems that we need. In terms of specialist facilities, Swinburne University has a significant astrophysics group, formed in 1998. It has focus areas in radio astronomy, in high-energy astrophysics, cosmology, and the like, and it also runs a significant compute resource which is dedicated to astrophysics called G-STAR. It's I'm pretty sure it's Australia's largest GPU system, which has around about 200 Tesla GPUs on 100 nodes. Victoria is also a focus area for life sciences, as Western Australia has a significant focus on geosciences. The Victorian state is very strong in life sciences. There's a lot of biotech companies based there, there's a lot of venture capital that's invested into Victoria. And to support that, the Victoria Life Science Computational Initiative provides services, computation and resources for that community across the academic and the commercial space. They have a petascale facilities based around BlueGene Q and x86 systems. And they also have the various infrastructure, such as large memory nodes to support genomics and visualization type facilities as well. Massive is an HPC facility that's focused on imaging. And in fact, it sits next to the Australian synchrotron, and that's its primary customer or supplier or driver, whichever way you look at it. But they also have developed expertise across the whole range of scientific imaging for areas such as microscopy and the like. And finally, last but not least, is the V3 Alliance, which is a Victoria-based HPC expertise. So they support research across Australia, advising on everything from HPC hardware, design, deployment, through to software development and science support activities. And so that was a quick wrap-up of Australia. In terms of collaboration opportunities, most opportunities for to collaborate with Australian researchers, and we certainly welcome it, is through focused scientific areas. We have a number of thematic allocations, as I told you, in radio astronomy, in geosciences, in life sciences, and our researchers are very keen to collaborate with other researchers from across Asia. For example, iVEC already has quite significant international collaborations, but if you look at the list there, you've got CSCS, Oak Ridge, NICS, EPCC. They're mostly in Europe and North America, but certainly for my sanity in terms of teleconferences, I'd much rather work with Asia because we're all in the same time zone. And so this is something we're trying to grow. There are already opportunities developing around SKA with India and China, but there should be lots more. Thank you very much.
Thank you. So we have completed the 7 reports, and we have 0 minutes to discuss some important issues. Please continue.
Okay. So as Tozuki said at the introduction, we are talking in the group about how we can better promote collaboration in Asia and across Australasia. And we're working on a plan that we hope will allow researchers to utilize computational time from the partner institutions and the member countries to support their research projects. Now, this is an in-progress plan. The intent is that we're looking for meritorious computational research projects, and a key is that it must involve researchers from at least 2 of the member countries, so that there is that cross-national collaborative aspect. Take advantage of the computational infrastructure. As you've seen from the site reports this morning, there is a diverse range of scale and architectures and types of computational infrastructure that's available across Asia, and we want to make that available to researchers. If researchers in one country do not have access to a particular type of resource that is of benefit to them, then through collaboration with other countries they may be able to get access to that resource. The expectation is that we're looking to run maybe projects of up to around about 12 months in duration, and the idea would be at each subsequent ISC meeting, we hope that HPC in Asia will continue to run for many years in ISC, this would be an opportunity for those researchers to present the science outputs and to engage the community in the work that they're doing. There's lots of things for us to do. One of the biggest challenges at the moment is that we have to establish what the mechanisms are to allow access for researchers. Various countries across Asia and including Australia have restrictions on how researchers from outside of those countries can access the resources, but we're optimistic that we can create a framework and a mechanism by which we can make these resources available. We then need to determine what resources are available and to create a call. What we're looking for just now is notes of interest. So if you're a researcher working in Asia and you would be interested to be involved in these projects and you have potential existing collaborations or collaborations you'd like to exploit, please come and see us. Keep your eyes open for the call, and if you would actually like to help us to develop this call and to be involved, we'd also be interested to hear from you too. Most countries, I'm sure, have usual channels through which they hear about computational science calls and research calls, so we will aim to put the call out through those channels, and you should be able to see that.